Welcome to LearnSphere. In this video, we'll learn how to solve right-angled triangle problems using trigonometry. Specifically, we'll focus on three main ratios, sine, cosine, and tangent, which you can remember using the acronym TOA CAH SOH. Here's what the acronym means. For TOA, it means that tangent theta, where theta is our angle, is equals to opposite over adjacent. For CAH, is cosine theta, where theta is our angle, is equals to adjacent over hypotenuse. And SOH, where sine theta, where theta is the angle, is equals to opposite over hypotenuse. Let's go on to a few examples involving TOA CAH SOH. For the first example, we have the question of, using the triangle shown, write down the value of each of the following, leaving your answer in the simplest form. For part A, we are asked to find tangent theta, for part B, cosine theta, and for part C, sine theta. The first step is always to label the triangles relative to the given angle and identify which side is opposite, adjacent, and which one is the hypotenuse. Firstly, we can start by labeling the hypotenuse. The hypotenuse is always at the opposite of the 90-degree angle. And in this triangle, the hypotenuse is xz of 13 cm, and we can label this hypo. Next, for the opposite side, it's the side that is opposite of the angle, which is 5 cm, and we can label this opposite. And lastly, adjacent, which is the side that is to the side of the angle, which is yz of 12 cm, and we can label this adjacent. After labeling the triangle with the given sides, we can go on to the questions. For part A, we are asked to find tan theta. Therefore, we can use the acronym of TOA, which means tan theta equals to opposite over adjacent. As our opposite side is 5 cm and the adjacent side is 12 cm, we can rewrite this as 5 over 12 as the answer. For part B, we are asked to find cosine theta, and we can use the acronym of CAH, which is cosine theta is equals to adjacent over hypotenuse. The adjacent side in this triangle is 12 cm and hypotenuse is 13 cm. Therefore, we can rewrite the fraction as 12 over 13. And lastly, for part C, we are asked to find sine theta, and we can use the acronym of SOH, which is sine theta equals to the opposite side over the hypotenuse. And as the opposite side is 5 cm and the hypotenuse is 13, we can rewrite this fraction as 5 over 13 as the answer. Let's go on to example 2. For example 2, we have the question of, in the triangle KLM, angle KLM is 90 degrees, KM is 17 cm, and angle KML is 32 degrees. And we are asked to find, for part A, the length of KL, and for part B, the length of LM. Firstly, we can label the triangle and identify which side is opposite, adjacent, and which one is the hypotenuse. With respect to the angle of 32 degrees at angle KML, the opposite side is KL and the adjacent side is LM. And 17 cm, which is opposite of the 90 degrees, is the hypotenuse. After labeling the opposite, adjacent, and hypotenuse, we can go on into the question. For part A, we are asked to find the length of KL, which is the opposite side. And we have another side, which is 17 cm, and it's the hypotenuse. Therefore, we have to use the acronym that contains both the opposite and hypotenuse. And we can use SOH, which means it's sine theta equals to opposite over hypotenuse. And we can substitute the values in to get sine theta equals to opposite over hypotenuse, and it's sine 32 is equals to KL over 17. To find KL, we can cross multiply the 17 over to the left hand side, which gives us 17 times sine 32 is equals to KL, and you can simply plug this into the calculator, and you can get the value of KL to be 9.01 cm as the answer. For part B, we are asked to find the length of LM, which is our adjacent side. As we are interested in the adjacent side, and we also have 17 to be the hypotenuse, we have to find the acronym that contains both the adjacent side and the hypo. And we can use CAH as it is cosine theta equals to the adjacent side over the hypotenuse, where the adjacent side is LM and hypotenuse is 17. Therefore, we can substitute the values into the formula, which gives us cosine 32 is equals to LM over 17. And to find LM, we can cross multiply the 17 over to the left-hand side, which gives us 17 times cosine 32 is equals to LM, and therefore LM is equals to 14.4 cm, correct to 3SF. Let's go on to example 3, where we have the question of find the unknown values in the following diagrams. So in this case, we have to determine the length of y, and we are given 12 meters to the left-hand side of the angle, and the angle is 48.9 degrees. Firstly, we can label the sides. Our 12 meters is to the side of the angle, and this is the adjacent side. And y is opposite of 90 degrees, and is our hypotenuse. So to find y, we can use an acronym that contains both the adjacent and hypo, which is CAH, as it is cosine theta equals to adjacent over hypo. Next, we can substitute the values that we have into the formula, which gives us cosine 48.9 is equals to 12 over y. Firstly, we can cross multiply y over to the left-hand side, which gives us y times cosine 48.9 is equals to 12. And as we want to find the value of y, we can bring cosine 48.9 over to the right-hand side, and it becomes y is equals to 12 over cosine 48.9, and we can simply plug this into the calculator to give us 18.3 meter as our answer. Let's go on to example 4, where we have the question of find the unknown values in the following diagrams. For this triangle, we have to find the value of x, which is the angle. And we are given 5.6 cm and 7.1 cm. The first step is to always label the opposite, adjacent, and hypotenuse side. And in this triangle, 5.6 cm is opposite of the angle, so we can label it as opposite. Next, 7.1 cm is opposite of the 90-degree angle and is the hypotenuse. And we want to find x, which is the angle. So we have to use an acronym that contains both opposite and hypotenuse. And we can use SO, as SO means sine theta equals to opposite over hypotenuse. And we can simply substitute the length into the formula, which gives us sine x equals to 5.6 over 7.1. To find x, we can bring the sine over and it becomes sine inverse. So x equals to sine inverse of 5.6 over 7.1. And we can simply plug this into the calculator to give us 52.1 degrees, correct to 1 decimal place for an angle as our answer. Thank you for watching.